We're exposed to particle accelerators in our everyday lives. Take the old cathode ray tube TVs and computer monitors, for example. They use an electron gun to accelerate electron beams onto a fluorescent screen, causing the point of contact to glow in a certain color. So then, on what principle does a particle accelerator work? Well, it uses electrical energy. A simple particle accelerator can be made by hooking up two parallel metal plates to a battery. Depending on the placement of the metal plates, the resulting electric fields pull and accelerate particles along. Quite simple, isn't it? Using these properties and principles, there are huge accelerators being built throughout Korea at this very moment. Of these, let's look at the Rare Isotope Accelerator, Raon, located within Korea's International Science and Business Belt. Raon will bombard nuclear targets with heavy ions, which have either lost or gained an electron, at speeds close to the speed of light. It will produce rare isotopes not found in nature yet. Raon will be about 800 meters long, and for this accelerator to be built, an area of about 133 soccer fields would be required. Raon will be able to accelerate different types of particles, from protons up to heavy ions. For the accelerator to work, it must maintain an ultra-high vacuum state 1/1000th of atmospheric pressure, with ultra-low temperatures below -271 degrees Celsius. Through Raon, we will be able to recreate the moment 3 minutes after the Big Bang, the moment particles were created, which means we will be able to answer how stars were created and even evolved. Raon is going to be a very special rare isotope accelerator. First, it will use a superconductor. This means it could generate enough energy to lift and move an entire train. Raon will use this superconducting material to accelerate particles. Second, in order to create rare isotopes, Raon will operate both an ISOL and an IF system at the same time, a world's first. The ISOL system accelerates a proton to smash an atomic nucleus, much like a bullet into an egg. The IF system, on the other hand, accelerates the nucleus itself to be smashed much like throwing the aforementioned egg onto a rock. Raon will take the rare isotope formed by the ISOL system and use the IF system to create an even rarer isotope. That's why Raon is so special and unique. The possibilities Raon could open for us are limitless. It can be practically applied in every industry out there, and newer, lighter, stronger materials can be developed through Raon. Raon can develop special materials that can be used in lunar exploration modules and satellites, and even eco-friendly high-capacity batteries for use in electric vehicles. Raon-created heavy isotopes can isolate cancer cells within the human body and destroy them selectively, without harming healthy cells around it. Development of new foods? Raon can be used there too. Melons that can grow at lower temperatures, grains that don't need fertilizers. Raon can be applied to usher in a new era of food resources for humans. Raon will be the pride and joy of Korea, with its core components built with domestic technologies, and will boast beam intensity outputs parallel to the highest global standards. It will highlight Korea's advanced technologies for the world to see, and through the recruitment and training of the world's talented researchers, Raon will propel the status of Korea's basic sciences forward. As a great opportunity to showcase Korea as a powerhouse of basic sciences and to bring global recognition, Raon will benefit humanity greatly and contribute to advancing society forward.